Okay, in the last video, I talked about testing hypotheses about the linear combination of the parameters. And I was discussing an example of a wage equation where we were interested in knowing whether returns to junior college and university education are equal. In particular, we were talking about testing hypotheses about the equality of two parameters. And I introduced you to this manipulation where we can tweak our model a little bit. And instead of estimating this model and then calculating the covariance between beta 1 and beta 2, what we do, we tweak our model so that we can get everything from the regression output so that we don't have to worry about this covariance. So I talked about this. So in this video, I'm going to show you an example in R where I will be estimating this model. This example is from the dataset 2 year from the Woolrich package. And first, I'm going to regress the usual model and get these estimated coefficient values for all these three parameters. And we see that all of these variables are statistically significant and these are their partial effects. And we are interested in knowing whether these two values are equal in the population. So what we can do is we can introduce a new variable, total education, by adding junior college and university as I showed you in the previous video. And instead of university, I'm gonna add this variable in the model so that the coefficient associated with JC, it will be showing us our desired hypothesis. So see here, the coefficient value for junior college, a negative number. And also it is not statistically significant. So t-value is minus 1.46. Okay, so here is the t-distribution and here is our hypothesis about this value. And we know this value is minus 1.46. And if we look at our t-distribution table at the end of your book, then we are in the one-tail test because we are looking at the left-hand side of this table. And our degrees of freedom, as we can see, is infinity because we have more than 6,000 observations. So we'll consider it as infinity. And at 5% alpha or 95% confidence, the value is 1.64. And at 10%, the critical t-value is 1.28. So that is our rejection region at 5%. And because our critical value is less than our calculated value, minus 1.64, it is less than minus 1.46, we fail to reject H0 at 5%. Now this is the 5% value. If we choose a different statistical value, now our rejection region is this. This is our critical t-value at 10%. We are rejecting our null hypothesis at 10%, but we fail to reject our null hypothesis at 5%. And if we calculate our p-value, then we will reject our null hypothesis at 7%. So based on this, we can conclude that returns to education are identical across junior college and university education because we do not have strong evidence against this null hypothesis. Okay, so this was hypothesis testing about one single parameter or a linear combination of parameters. In the next part, I'm going to talk about testing multiple linear restrictions using the F-test that we use to test multiple restrictions on a particular model, and test exclusion restrictions using the sum of square residuals by calculating restricted and unrestricted models. And later on, we're going to use R squared to calculate F-test. All right, I'll see you in the next video. Bye-bye.